All right. Hope this is recording. Okay. All right. Officially, you're welcome to another session of our POD discussion. And in today's session, we are discussing Varadic functions. Variadic functions. And as we do always, anytime a concept is mentioned, there are about 4 major questions that you need to get answers to. What is this concept about? So what is Variadic function? Why do I need to know about it? When do we use it? And how do we use it? Okay, so at least, if for nothing at all, you should be able to get answers to these questions. And that is how you get to understand the concept. So hopefully by the end of today's session, you'll grasp or you'll find answers to all these questions, okay? And what I also usually like to do is to help build on something that we already know. So variadic functions, these are two terms. We have here variadic, then you have here functions. So let's start with functions. We already know what functions are. We've dealt extensively with functions. If you are here and you don't know, or you'll be watching this video and you don't know, we have already published a video on YouTube that you can access how to write functions in C. Okay, so basically, just as I said, we are looking at what they are, what variadic functions are. We'll be interested in why we need them. We'll also be interested in when we are going to use them. Then finally, we'll be interested in how to use them, okay? So anytime at all, when you start learning on your own, any concept, especially when a concept is new to you, put down these 4 questions and try answering them. So the first thing you need to know, what is it? That's the first thing that you need to appreciate. What is variadic function? So just as I said, this is coming from 2 words. Variadic is coming from the word variables or variety. Okay, that means that it's not a constant, like it can change. The amount of something that can change. All right. Then what can change in functions? When we are declaring a function or when we are creating a function in C, we all know that we need to state the data type that is going to be returned. Okay, so we say the return data type. Then we need the name of the function and a parenthesis. And inside the parenthesis, we are going to provide some arguments to the function. So this is how we declare a function, and that's how that's a template for a function or the prototype for a function, as we call it. For that matter, we are interested in what can be a variable or what can change here. What is not supposed to be constant if you are dealing with variadic functions? This arguments. Okay, so all this while, whenever we are writing a function, what we do is that we indicate the total amount of arguments that the function is going to take. That's what we've been doing so far. So for instance, if I create a function called sum that returns an integer and takes in 2 integers, I write it like this. Okay, this is how I express it. The function called sum takes in 2 integers. So there are 2 arguments here, and there is the return data type, which is also an integer. And almost every type of function we've been dealing with is of this sort. That means that the number of arguments has to be fixed. Someone is talking. Okay, sorry. Yes, so that means that the number of arguments in here has to be fixed. But if it is always going to be like that means we don't even get the flexibility to choose the number of arguments at runtime. Like when I'm running a program, can't I decide that, okay, I want to have, okay, this sum function that we have here, let's assume that sum is supposed to be adding numbers. Okay, so over here, we are going to define it as return probably x plus y. Okay, and this will be a perfect function in C. Once I have something like this, anytime I'm calling sum, The only set of numbers that I can apply sum on is 2 numbers. I can't have more than 2. So if I do this 3 and 4 and I want sum to add them up, I'm going to get an error. The reason being that per the definition here, sum is supposed to take only 2 arguments. But what if I want to create sum such that it can take multiple arguments depending on how many values the person wants to enter? Will you end up creating a calculator and restrict the user to the number of inputs the user has to add? Would that be an effective calculator? That's a big no. So if we want to be able to do certain things, certain useful things in C, we have to also permit the end user to be able to determine how many things they want to put in the function that we have created for the function to do the exact thing that we want it to do for them. We are building on. So Variadic function is just any function at all that takes a variable number of arguments. A variable, so that is where it's getting its name from. A variable number of arguments. Please don't confuse this variable. This is just an English term. Don't confuse it with variables that we have been talking about. It just means that the number of arguments can change. Okay. So somebody using the same function can input 2 arguments. Another person using the same function can input 3. Another person using the same function can input 4 or more. Like it can be as many as possible. And that is only possible through the use of Variadic functions. Okay. So now we've looked at the what and the when. Why? Okay, because the why we are looking at anytime we want to allow that flexibility to allow people to enter the number of arguments for their own choice, depending on what they want to achieve. We should be able to allow them. So basically, that is what Variadic functions are and why we will need them. So essentially, the focus for today's lesson will be on how to use Variadic functions, okay? Hopefully, we all understand Variadic functions. Once we want a function to take up a variable number of arguments is a Variadic function. Now, how do we implement that? That is the big question for us today. So we are going to be playing with our sum function. But a quick introduction to how we implement Variadic functions.
Work is fine as well. Yes.
Come again?
But Sima told me that your phone was bad recently, but
let's be careful. Okay, so to be able to use the Variadic functions, let me call it VF, sorry, VF. To be able to use Variadic functions, okay, there are some inbuilt macros that are already available for our use. So this one, it has been predefined. Predefined means that the way those macros are going to be used has been predetermined. So all that you are going to learn here is that these are macros that are available for your use, and this is how you use them. That's all. You don't have to reinvent the wheel. The macros have been put there such that anytime you want to create or use a Variadic function, just follow how they are supposed to be used. So your own task here is just learn how each of these macros is supposed to be used. Once you know how the macros are supposed to be used, you can always use them the way you want. So there are 4 major macros that we need to learn about. The first one is called va_lists. The second one is called va_stats. The third one is called va_arg. Then the last one is called va_end. Ima, do you want to say something?
Doc, sorry for interrupting. What do you mean by macros?
Oh, okay. All right. So I was presuming that we all know what macros are, but basically, macros are like how will I call it? Aliases. Okay. Like nicknames. right? So for instance, let's say if I create a macro in C, usually do this, define, then you define something. So I can define pi, then I say pi is equal to 3.142. This means that in my code, the code that I write, okay, anywhere you see pi, they are for pre-processes. So the preprocessor will pre-process it, and anywhere it sees pi in my code, it will replace it with 3.142. So you realize that writing 3.142 each time is not convenient, or maybe it's a longer thing. It's not convenient. For that matter, you define a macro that is like an alias or a nickname for this. So this is, let me say, we call it pi. So anywhere I'm supposed to actually write 3.142, I write pi. Okay, and the computer or the preprocessor will understand it. And before you even compile the code, that is before you get to the actual compilation stage, the preprocessor will remove all the macros and replace them with the actual values. So basically, that's what a macro is. But fortunately, we can create macros that are kind of functions. Okay, so these are like macros that are functions. So basically, in the code, va_end means something more, but it has been abstracted. Right now, we don't know exactly what va_end does. If we check the standard header file, which is their header files, I mean, standard arg.h. If you look into standard arg.h, you are likely to find what these macros actually represent, exactly the format, whatever they are abstracting that we cannot see. You are going to find it in this header file, okay? So probably you can take your time and just Google this file and see what these ones are in there. But basically, all that they are doing is that it's like they have created a function, okay? And the function takes, as a function, even though it's not technically a function, but this is macro function. So it behaves like a function. And what it does is that it takes some arguments and it has an expression that will tell the computer exactly what to do with that argument. But now we are not interested in those nitty-gritties. Okay, in the same way, if we are writing pi, I'm not interested in the actual value of pi. Let me just be using pi anywhere I need to use it. I don't have to go and be learning about it. So we don't need to go and learn about the actual thing that this macro is abstracting for us. We don't need them at all. All we need to know right now is how do we use these macros. Okay, so hopefully that explains macros to you. They are just aliases that we use to represent something. Okay, it could be anything at all. You use it to represent it so that your code becomes easy to read instead of all this cumbersome stuff. But the preprocessor will remove, these ones will not enter the compilation stage. The preprocessor will replace them all from your code. It will replace them with the actual thing. Okay, so all that you need to know in order not to confuse yourself is to know how to use each of these. And therefore, so let's take a look at them one after the other. The first macro, va_list. What is it used for? It's used to give a name to the list of variable arguments that we have. So I think I should represent this. When I wrote the sum function, I did this and I said int x, int y. Okay, that's what I did. But if it was supposed to be a Varadic function, then the nature would be something like this, where let's say int x, int y, comma followed by dot. In our normal expressions, English or whatever language you're writing, usually when you see dot, it means that there is more, right? That's what it means. There is more. I'm just deciding to cut it short here. So that's the same thing that we are doing here. This is telling us that there are more to this. Like we have a number of arguments that I've not listed here. Okay, so some of us will write examples of so and so are 1, 2, 3, ... meaning we have more. Okay, that's exactly what is happening here. We have more of this. So this is how variadic functions are represented with the help of this ... So when the compiler sees that ... it knows exactly that there is a list of other arguments that has not been stated. So that list of arguments, assuming that we had, let's say, 4, 6, 8, 10 as a number of arguments that we couldn't write. Whenever you define this macro, give it a name. It means that that is the name of this list. Do you get it? So there is a list of arguments that we haven't indicated, but by stating or giving a name with the help of this va_list, which is a macro, it gives a name to that list. Okay, and that list could be anything, because it's at the end of the day, when you are using the program, when you are running the program, that's when you determine what those values are. So it is at runtime that the list will be determined. For the ones that we are going to write here, since we have made them fixed, we have to provide them. But for the variable ones, they will be provided when the program is running. So assuming I've created this sum function and I wanted to add as many numbers as possible, this means that when I am running the program, or if I have created this calculator, simple calculator, and I've given it to you and you are going to run it, you should be able to enter as many numbers as you want. And that extra set of numbers that you are going to enter, it's a list of them. And we can only identify them with a name. So we will choose what we call them, but you preface that name with va_list. So va_list, then call them, say, my numbers. Okay, so if you do this, all that you are saying is that that list of variable arguments that you are going to input, you have decided to call them my number. And you can only do that by prefacing it with va_list. So this is like declaring the name of a list. So anytime you write va_list, you are declaring the name of a list. So some of us will decide to call it list, which is fine. Others will call it va_. You see some people call it args, which is for arguments. It's fine. You can call it anything you want. The only important thing for you to know is that anytime you use va_list, what follows is the name of the list that you are going to pass. So I prefer to choose a name that is in line with the function that I am creating. What kind of list am I expecting? So in this sum, probably I can decide to call it my numbers, because I am looking at the numbers to be added. Or okay, I could also call it numbers to be summed. Okay, numbers to be summed. That can be the name of the list, but you decide. The only important thing is that you should write va_list before you write the name of it. I hope that is clear. Now, after you have created the list with va_list, so now let's call this list my numbers. After you have created this list, the next thing is that you have to initiate the list. Tell the list, where do I begin counting from? Because this function that we have, let me write a function here, int sum, say int x, int y, then ... This function prototype that I have here, where should I start counting the list? Where should I start counting? That list we are talking about, where should I start counting? Okay, so we initiate it with va_start. va_start is the macro that will tell the compiler where to start picking that list, the values in that list from, or the arguments that make up that list. So it's telling you that, okay, from here onwards, this belongs to this list. Okay, and this is actually a function macro. So it takes arguments as well. It takes two arguments. The first argument is the name of the list. And the second argument that it takes is what precedes the list. What is the very last thing that comes before the list of those variable arguments? So in this, our example, you realize that int y is what precedes this list, this variable list, okay? It is the only thing that comes immediately before the list that we have abstracted, the list that we didn't include, but we have indicated that they are available. Take it in easily, slowly. Okay, let it not confuse you. The first thing you did was to give the list a name. Okay, and I've told you that these ones you've provided them, so you don't have a problem with it. But the ones that you've not provided them, that is what we are trying to put them together as a list so that we can access each of them. And we've given them a name, my numbers. But this what the computer or the compiler wants to understand. From where should I start counting this list that you are giving me? From where does it even start? So what I do is with v_start, I give it the name of my list. So in this case, my numbers, comma, then where does it start from? Here it starts from right after integer y. Okay, so I have to pass y here because it starts beyond y. Once I do this, the preprocessor processes it, and the compiler now understands that the list is anything after y. So it will count anything after y as part of the list. Are we okay with that? So variadic functions is actually a simple concept, and I believe the only thing is for you to understand just these two, and I think the last one that we are going to talk about. But before I talk about it, I want to make sure you understand this. v_list is for the numbers. I mean the list. Give the list a name. That's all you want to do, because going forward, you are going to be using the name. Okay, going forward, you are going to be using the name of the list. So you can't have a list when you have not created a name, like you haven't given the list a name. For us to be able to access all the variable arguments, we need to have a name of that list. So that is the very first thing that we do if you want to use variadic functions. We have to state the name of the list. Then the list cannot start, like you have just given it a name, but it doesn't know where to begin counting from. What actually makes up the list? So all that you have to do is to call the macro va_start and pass the name of the list to it, and pass. So this is name of list. Then this is arguments. The arguments that precedes the list. So what's the last argument? Or let me add up last argument that precedes the list. So we can have as many of them. So this our sum function could have int x, int y, int c, int d, comma, int e. Once all of these ones you are providing them, so they are not part of the variable list. Okay, the variadic list, they are not part because you have stated specifically what they are. So they are not part. As soon as you bring this, let's see, dot, the 3 dots. Now, this is where the list actually is. This is what you have abstracted, and you are going to allow the end user, the person using your application, is going to add whatever they choose to add there. But here you have predetermined all of these. So to tell va_start, like to initiate the list that you are creating, this list of variable arguments, you just have to pass what is that argument that comes immediately before the list, so that this particular va_start always is looking for that one. So if I pass E here, then it knows that anything beyond this is part of the list. And it's going to capture it into that list so that we can have access to it. So we've talked about two of them, v_list, v_start. Then the next one, v_arg. Okay, and this is the arguments. The arguments that is the individual members of the list. So now you have created a list, or you have assigned a name to the list. You have initialized the list by using v_start. We know exactly where they begin. But once we begin it, we need to have access to each of the members in the list. So if there are 20 of them, we should be able to have access to each of the 20. So how do we use v_arg? It's also a fancy macro. So it takes the name of the list, which we have already created as my number. So the name of the list, my number, then comma, what type of data? So here it takes the data type. Is that member there? That member that we are looking for, that specific member we are looking for. What is its data type? Is it an integer? Is it a string? Is it a double? Okay, very important. So this is what the v_arg takes. So if we had two members, this is very interesting. Please pay attention to this. What happens is that let me assume that the variable number of argument the person entered in our sum function is this. Let's say the list is 41, 52, 73. Let's say there were 3 integers that were entered into this is at runtime, and the person has entered 41, 52, 73 as part of that part that we made room for. Okay, when we start a practical, you get to see how it is actually used. Okay, but I'm trying to explain the concepts behind their use. So 41, 52, 73 are the members of that list. When you call v_arg, what you are doing is pass the name of list to it. So my number, that's the name of the list, comma, what is the data type here? This is an integer, so you pass an integer to it. This is going to equate this whole thing in your code. Remember that this is a macro. So in your code, when the preprocessor processes this is the first time you are calling v_arg. It's going to replace this whole thing with 41 because that is the first member of the list. So even before we go to the compiler, by the time the code is at the actual compilation stage, we don't have anything like this in there. What the compiler can see is 41. If you go ahead and call v_arg again and pass my number to it, comma, integer, which is the data type there, you have already gotten the first value. It has taken out the first value already. So the second call will go and pick the second value. So in the code, this will be replaced with 52. If in your code, you still go ahead and call it again. So anytime you call VA argument, it picks the next argument. You created a list, you initialize the list. Okay, so now your computer understands whatever the list is, whatever is in there, and you use va_arg to have access to the members in that list. But va_arg is said that anytime you call it, it brings you one member. So the first time you call it, it brings you the first member. The second time you call it, it brings you the second member. The third time you call it, it brings you the third member. So if you want a 4th member in a list, you have to call it 4 times before you get the 4th member in the list. But what is important here is that by the time your code is going into compilation, remember that this is a macro. So this is going to be replaced with the actual value in the list. Very important. Then finally, after you are finished, so let's access the last one. Number. You might want to ask a question? Yes.
Sorry for interrupting you. This VA ag, my number, can it have two types of different data types, apart from having one particular data type? Can it have like you have int, char, or maybe float?
Okay.
In the same.
Okay, so let me answer that question right now. All right. So that is possible. It only depends on what you put in your list. So assuming that the list was, let's say, my list, okay, and the list is actually what we entered was first my name, which is Obed, and probably my age. I won't write my age anyway. So let me write 16 there. Obed, my age, and say my which one will be a character? What will I use that will be a character? Okay, my sex. So I'm a male. Okay, or gender. Let's assume this was your list. Okay, so there are 3 things here in the list. The first time you are calling v_arg, you pass my list to it. Then the first data type is a what? It's a string. In this case, it is a character pointer. Because in C, that's how we refer to strings. It's a character pointer. If I do this, then this will be replaced with Obed, because that is the first member of Obed of the list. If this was the first member of the list and I decided to put int here, I'll get an error, because it will go into the list and check what is the first member of the list. It is not an integer, therefore this is wrong. Once this is a string, you have to indicate that it is a what? A string. Let me add the last member. So let's call this my height, and say my height is 1.2 meters. Okay, so let's just use 1.2. All right. So the next time we call va_arg my lists, what data type is there? Is an integer. So you pass an integer in here. Then this gives you 16. The next time you call it arg my list, what's the data type there? It's a character. But the way this va_arg has been designed, it forces characters into integers. So you can't put character here. It's not acceptable. So whenever you have character, you still have to quote it as integers. Please don't come and ask me why. The thing is, this macro has already been defined. This is how it works. And I have not even bothered to go and look at the header file to see how they describe this. The only thing that I need right now is how to use it. So what we need to know is that if it is a character, we put int here. If it is an integer, we still put int there. That is what this v_arg knows. It doesn't know character. If you put character there, it will give you an error. But it accepts character pointer as a string. But for normal characters, it takes it as integer. Maybe if you're curious enough, just go check the std_arg.h file and see how this v_arg was implemented to be able to take integer but rather print out characters. Okay, so this will now give us m as the character that we are looking for. Then if we call it the last time, this is my _list, comma. Unfortunately, it also does not take floats. So you can't write float here, you have to write double. Okay, so character, you write integer, float, you write double, and this will give us 1.2. The essence is that any number of times that you call it, if you call it the first time, So if in your code you call it just one time, it's going to bring you just the first member. If you call it twice, it will bring you the first and the second. 3 times, it will bring you first, second, third. 4 times, first, second, third, fourth, in that order. But you should know that your list should have an end. Your list should have an end. If there are 4 of them, and I go ahead and call the 5th one, there is nothing like that. So I'm going to get an error in my code. There is no 5th one, hence I shouldn't call a 5th one. Otherwise, I'm going to have an error in my code. And to signify to your code or the compiler that you are done accessing the members of your list or the members that you want to use for now, to signify that you are done with them, you have to pass v_end macro and give it the list. So just as you started or initialized the list, by doing this, you have ended the list. So that is how we use the 4 macros in Variadic functions. v_lists is used to give a name to the list. Give a name to the list. Then v_start is used to initialize the list. Tell the list where to begin from. Okay, so initialize the list. Then v_arg is used to access members of the list. Members of the list. Then finally we have v_end, which is used to signify the end of the list. The end of the list. As simple as that. So every other thing that we are going to be doing has to do with all the things that we've done before with our functions. But now, to access these members or variable arguments that we are adding, we'll just bring in these ones. That is all. So in fact, we are done with Variadic functions. Yes, Ima.
Hi. If you want to access the members, are you going to start from the example that you gave, like int s, int y, then those ...
Okay.
As in when you are using varg.
No, the varg will only access the ... whatever was provided there. So anything that you wrote before the ... you are not going to use varg to access them. Those ones you access them by their names. Okay, you access them by their names. Like when I wrote sum and I wrote int x, that's what we are used to, int y. Just like this, I could go in there and say return x plus y. But when I write sum, so let's say when I write sum, say int x, comma ... I can't come in here and use the ... but I can come in here and use x, say x plus plus. It is possible for me to use, but how do I access these ones? That is when I have to initialize, I have to give a name to this list, initialize it, then I'll be able to access each of the members with varg. Then when I'm done, I'll end it. Okay, so on that note, let's take note of this, that there should be at least, very important, at least one argument before the Varadic ones. So, why did I cancel it? You should have at least one. You can have as many as you want, but at least there should be one before you introduce this. This means that you can't create a Varadic function like, say, int sum and ... This is not acceptable. There should always be at least one here, at least one here. Remember that when you are going to initialize the list using v_start, what do? You give it the name of the list, then you give it whatever comes before the ... so that it knows where to initialize the list to. So if you just write some ... the question is, how are you going to initialize this list? It's not going to work. So you always need a minimum of one argument. So we call those ones the mandatory arguments. These ones are optional arguments. So whoever is going to use your function afterwards can decide not to enter any arguments here. The list, you can decide not to enter anything in there, and that's fine. And your function is going to work the same way you want it to work. But if you leave the mandatory one out, it's not going to work. And you can add as many mandatory arguments as you want, just as you work with your functions. So that is the point worth noting. So for Variadic functions, always you need to have a minimum of one argument in the function before introducing the ... Then we access them using the macros v_list, v_start, v_arg, v_end. And we've seen how each of them is used. Any questions? We are going to move on to code.
I have this question, like let's say you have at least one argument.
Okay.
I did not get how you explain that you would access the next one. Like if you are calling, if you are accessing it, how would you get, for example, you have these members, then you specify at least one argument, and then how would you call the other one, the next one?
This, right? That's what you're saying.
Yeah.
Okay, so inside this our function, we can go ahead and use x, like the way we will use it. So just as I did, x plus plus. That means I'm adding 1 to whatever x value is. That becomes my new x. Then if I want to access these ones, I have to first start by giving a name to the list. So call it, say, my values. Okay. Then I have to initialize that list by using v_start and pass the name of my list, which is my values, comma, what comes before the list. Okay, the argument that comes immediately before the list. So here it is x. Then I can now go in and use v_arg. So if I use v_arg, pass my list to it, then the data type, assuming that I expect integers here, pass integer. This gives me access to the very first value that the person will provide as part of this variable list. Then if I call it again, I get a second. If I call it again, I get a third until I want to end. And you have to make sure you don't go beyond the total number that you have, because it's a limited number. Definitely, you're going to enter a limited number. Does that make sense?
Thanks so much.
You're welcome. Okay, is this thing open? All right. So let's bring up. Okay, so let's call this, we'll call it Varadic functions underscore PLD. Okay. I was happening. What's happening here? Okay, so Let me open VS Code. Let's work there. No, this thing is taking the whole screen and I'm finding it difficult to see. Okay. All right. Interesting. Okay. Now let's open the folder. All right, let's call the first file sum.c and try sum out. Include same std stdio.h. Oh, okay. We are starting from what we know. Okay, so let's create the main will be say int main then return 0. All right. Then let's create a function called sum. And sum takes in two inputs. We have can you see my screen? Well, I hope it's okay. Let me go back one. Okay. So this sum function will take two arguments, int x and y. This is the normal things we've been doing just to refresh our minds on that. So what we can do is we can declare another integer called say results. Okay, then we can, this is, I'm just trying to be explicit enough for everyone to see exactly what's happening here. So say results is equal to x plus y. Then we'll return results. Once we've created this function, we need to declare the prototype up there. So copy this and put it up here for everyone to see. Good. Now we can access that function inside this main function. How do we access it? Let's also create, let's say, there are easier ways to use them, but I just want to be explicit enough for everyone to appreciate, no jumping any steps. So let's say int n. Let's declare int n. Then now we say n is equal to sum of 10 and 4, which we all should know the answer. So hopefully when we compile this code, sorry, we are not displaying anything to the screen. So let's print n, print f of %d, then n. So hopefully when we run this, we should get 14. GCC has the output to sum. No input for, oh, CMU. GCC sum pass the output to sum. Okay, now let's run sum. 14. Good. And hopefully everyone gets this one. You see what's happening here. We are taking two arguments, x and y, and we are able to use them in here. And when we come, this is how we call the function. And once we have specified that we are supposed to pass two arguments, you can't come and pass just one argument. Okay, so if somebody wanted to pass just one argument, they can't. Let's try that and see. Run this. See what it's giving us. Too few arguments to function sum. So that is where the problem is coming from. Too few arguments. Now let's go to, what if I want to add 3 sets of numbers? Would that also be possible? So we run this again, and it says too many arguments to function sum. So this function here always will require a specific number of arguments, because that is what we have declared here. It requires only 2 arguments. So anything more or less will give us an error. Let's compile this. This has compiled because we have only 2 things there. Then we run it, it gives us the correct answer. 10 plus 45, that is 55. Good. So that is where the challenge is coming in. How do I write it such that I can get this sum function to compile more than 2 arguments? What if the user enters more than 2 arguments? How can I get that? Okay, so let's try another one. Create sum1. Save this as sum1.c. Okay, then for sum1, in order to be fast, let me just copy this, then we update it. Now we want to introduce Variadic function, so we'll include standard arg.h. Okay, standard arg.h. Then in here, we are going to do this. So that's how the prototype is supposed to be. 1, 2, 3, 3 dots. Let's go on. Then come to the main one. Then we also pass 1, 2, 3. Good. Now, I just want us to try something which I haven't tried before anyway. Let's compile this code and see. It's compiled, no errors. Sum, it's given us a 55. So even though we have passed this and we haven't utilized it anywhere, it works fine. Okay, that means that these are the mandatory ones. Like once you've stated them in here, they are mandatory. Any other thing beyond this is optional. So now that we have done this, you realize that earlier on, when we passed 3 arguments, it gave us an error. So let's see here. Now we have 3 arguments. Let's compile again. It compiled all right. Then we run, we get our 55. Pay attention to that. We get 55 because the essence of me doing this is just to show you that now we've made it variable. Like we can add more than the 2. The 2 here is mandatory. So we can't give it just 1. If we give it only 1 mandatory, then we can give it just 1. But we give 2 mandatory. For that matter, anytime we are going to use this function, in this case, we have to provide those 2 arguments. Those ones are mandatory. But we can add as many as possible. 65, 70, whatever. We can add, then run the code. And the code will run successfully. But it doesn't appear in the sum because we haven't written any code to specifically add them up. The only code that we've written so far in the definition of the function is that it should add x and y. So we haven't touched these other ones. We are yet to even touch them. But what makes this nice is that now whenever we are calling our function, we can call with more than 2 arguments. Unlike in this case, we could call it with only 2 arguments. More than 2 was unacceptable. So that's the power that Variadic functions gives us. We can pass as many arguments as we want in here. So let's initiate a list. Okay, before we do the addition, let's initiate a list. We initiate the list with a macro v underscore list. Call this my numbers as we've been working with. Okay, my numbers. Then we have va underscore starts and v underscore starts, and this will be my numbers. Then comma. What is the argument that comes immediately before this dot dot? That is y. So we pass y here, y. Okay. Then what did I say? Anytime we use the v underscore arg, we are going to get the first time you use it, you get the first one. The second time you use it, you get the second one. So let's go ahead and presume. Let's presume that we know that. Let's see how many are here. 1, 2, 3. There are 3 of them here. So let's presume that we know that you are going to add 3 of them. Okay, we know that you are going to add 3 of them. What can we do? And those 3 are words, integers. So if those 3 are integers, something I've not tried before, but I like to try. Va underscore arg, then pass my number. Okay, my numbers, comma, int. So this is for the first one. Then let's add the second one. Va underscore arg. What is it? My numbers, int. So let me end here. Then come down here and say, oh, I've ended. So va underscore end and pass my numbers to it. So what do you expect here? Someone should share with me. What do you think? From what the definition I've written for our function right now, what do you think is going to happen? Explain the code for us, especially just this part of the code, the definition of the function. Anyone? Yes, anyone? Are you there? Yes.
I think it will take the first numbers and that's the one we had before, and then this argument, they call for this number, it will take the other number again, and then it proceed to the next one. So and then it give us the result.
Okay.
Like
all right. So
yeah.
All right. Thank you. So just as you were saying, the mandatory ones are these ones that we have provided, x and y. So whatever values come first that you provide when you are calling the sum, the first 2 are the mandatory ones. So those ones will be added up, and hopefully this should give us the first element in the list. Then this should give us the second element in the list. Remember that in that optional list that we have created, from how we called it here, we gave 3 elements. But since we called v_arg only 2 times, we are expecting that it's going to add this. That would be 70 plus 80 plus 45. That is 125. So hopefully, if everything should go right, it should give us 125, excluding the 89. Excluding the 89. The reason is that the 89 is the third element in the optional list, but we called v_arg only 2 times. Let me run it and see. I hope it doesn't give me any errors. Okay, great. Now sum. Oh no, it's not. That's quite interesting. So it's not giving us the number. Okay, let me try this. Let me abstract this, okay? Then pass it to, say, int z is equal to this. Then int k is equal to this. Okay, so let's try this and see why. Then let me add plus z plus k. Hope I'm doing everything right, because if everything is right, it should work.
Int k, top, int k, semicolon.
Which one is that?
Int k, semicolon, int k.
No, I'm assigning it to this.
Line 22. Line 22, semicolon.
Oh, okay, here. So why didn't you throw an error? Minus. Oh, holy shit. Guys, I've been compiling the wrong code all this while. I've been compiling sum.c instead of sum1.c. Oh my goodness. Sum1.c. Because once that semicolon wasn't there, it should have given us an error. So if it wasn't, then there was a problem. Okay, so let's see. Yes. So the first one should have worked. we're actually compiling the wrong code. Okay. But I hope it makes sense. So if we go ahead and now we add this, I'm not saying that this is the ideal thing that you are supposed to be doing. We'll get there. But what I'm showing you is exactly how they work. Okay, so just follow closely how they work. Anytime you call v_arg, you are calling one of them. So the first time you call it, you've called it once, then you look for another one. So say m. Okay, then let's add m to this. M to this. And compile our code again. This time around, let's go back and see what we expect. This is 10 plus 45 plus 5 plus 65. That was what was given as a 125 plus 89. So what will we get? The mathematicians amongst us, what will we get?
230.
Okay, let's see. Then let's run this. 214. You missed one of your marks. Okay, so basically this is to illustrate how we get access to each of the elements here. Okay, each of the elements in here. But when you go ahead and write them explicitly like this is you trying to force that they should be like 3. I'm tempted to do this. Let me do it and learn what will happen. So do you see the potential issue here? We have stated that These are variable. We need 2 mandatory, which is there, but these are variable. And in the list, we provided only 2 things. But in our definition, in our definition of the function, we've tried accessing more than 2 things here, because we've called this, and we've called it again. Meanwhile, the person has only supplied 2 arguments, 2 optional arguments. So this should potentially throw an error, but I'm guessing that it may end up giving us some garbage values. And since I've not tried it before, I wouldn't let it pass. I'll still go ahead and try it and see. Okay, this compiles successfully. Run 125. That's interesting. So it added up without giving us any issues. Okay. So that is what makes it flexible. Just as I said, I hadn't tried this before, so this is good to know that even when we call it beyond what was supposed to be called, it didn't give us any issue. But I believe that it may be compiler dependent, and therefore, if you call beyond it in certain compilers, maybe you may get some issues. Probably it will bring up some garbage values for you. Okay, but the essence of what we are doing right now is showing you how we can make this function so that it can take variable number of arguments. But to enable us to use it efficiently, what we can do is that, why don't us, instead of going ahead and explicitly stating each of these, why don't us use a loop to loop through the list, so that we do not even know, we shouldn't even know beforehand how many numbers that a person is going to enter. We are just writing our function such that no matter the number of elements they enter, we should be able to add them up. That makes it more useful than it is now. Because as it is now, if I want to add specifically 3 things, because if I go ahead and I introduce 4 optional arguments, there is no way this function will add this number. It will add only up to this number, because that's what I have written the definition for. And if I add any extra, it will not be able to do that. So we have to write our code such that we use a loop to loop through the optional list. We're going to loop through the optional list and add each of them. So with the help of loops, when we are working with Variadic functions, they become so useful. We go through each of them. You know that this person provided 50 elements, 50 lists. If we are supposed to print them out each, we have to use a loop to walk through them and print each of them out. If it is summation, as we are doing here, we have to walk through each of them and sum them up. So how then do we do that? That's what we are going to look at. Because it is going to be a loop, and by now you should know that anytime you are using a loop, you should have an idea when to break out of the loop. So in this specific example, sum, the list, we need to know, you the end user that you are writing, the values that you want us to sum up. We have to find a way to tell how many elements are there, so that we'll use our loop to walk through each of them and add up to sum. Does that make sense? So that if this person is adding 5 extra things, 5 extra numbers, okay? If this person is adding 5 extra numbers, that's 1, 2, 3, 4, 5. There should be a way for us to be able to go through it and count. This is 1, 2, 3, 4, 5. Once we know that there are 5 of them, then we can now use a for loop or a while loop. Let's say a for loop to check for, let's say we'll set a count or a variable count or a variable I is equal to 0. Then we check if I is less than 5. If it is less than 5, go ahead and add a value with the help of v_arg, add a value to sum. That means we'll go through the loop and add all the 5 elements. If the person added 10 elements, then we'll go through the loop to add all 10. If the person added 500 elements, we'll go through the loop to add all the 500. So the question is, how are we going to be able to tell that this person entered 5 The other person entered 3. The other person entered 15. How are we going to be able to do that? And that is a problem. It's quite unfortunate. There is no easy way for us to go through and check the number of elements the person provided beforehand. Because this code you are writing here, even though you can see me putting it in here, practically I would have left this space empty for the end user to be entering their own data. Okay, so we can use scanf to take in the data there. So what I am building, assuming that I'm going to be putting the data from scanf, I'm going to be inputting those ones in here. Okay, that means that at the time I am coding this, I don't know the values that I'm going to put in here. And I don't know how many values the person is going to enter. If I write this program and I give it to you to do your summation, I don't know how many values you are going to enter. For that matter, to make it that flexible, the best thing for me to do is that I have to ask you yourself, how many values are you going to be adding up? That's the best way that I can tell the number of values you want to add up. Then I'll write my code such that my code is going to add up all those numbers in there. So if it is not just numbers, I still will find out how many elements are you providing. Better still, depending on how you write your code, the essence is that you should use some external means to get the total number of elements. So maybe in your code, you would have done something. Maybe you have declared some variables that the person needs to fill, and you're going to check which of them were filled. So let's say that you have used this program to write, like let's say you've written a program where the user needs to provide information, and you're going to print that information out. Say your name, your password, your email, your age, your gender, all those ones. But for each of them, you check which one is not empty, which one is not empty. Then you check, okay, the person provided only 4 out of 10. That means that when you're coming into your Variadic function, you know that the person provided 4 elements. So you make room for only 4 elements. So what I'm saying is that to be able to do this correctly and access accurately the total number of elements in the variable argument or in the list that we are going to create, we have to do that externally. Okay, so either you ask the person directly to input the total number of elements they are going to put in there, or you use some external means to calculate the total number of elements that has been put in there before you pass it to your function. So let's use an example. Let's assume that this, so since remember that I said the mandatory is only 1, like you need a minimum of 1, okay, or at least 1. I said that. Therefore, now what we can do is that this y value should, in our own case, should be like the count. How many? So let me, if you call it count instead. How many elements are you going to add up? It doesn't mean always it's going to be how many elements you are going to add up, because you realize when we're using the int x, int y, it wasn't how many numbers. But to make this more useful, okay, so that we'll be able to cap the list, we will know exactly how many numbers in there. We usually want to include this. And we could have included this like that, and we could have also added x and int y the same way we did it. It's allowed. The only concern is that we are just introducing a variable that will give us an idea of how many elements the user is going to input apart from the mandatory ones. So if you look at this, there are 3 mandatory ones. That means that these are the optional ones: 1, 2, 3, 4. So the user who is going to add up these numbers, we expect him to come and tell us what count is. So if there are 4 optional ones, then we expect him to say count is 4. For that matter, this will be 4, because that's the variable that we are passing to count. I hope no one is getting confused. Let me take it again. We have done all that we are doing. Okay, we have done all that we are doing. Okay, but our concern now is that with the optional values, okay, or the optional arguments, we don't know how many of them, how many optional values were provided. Okay, so this is only important for us to be able to get the exact number in the list. Directly in our code, there is no way for us to go through and get the exact number of the list, because the list will be added, like because in our example I am already adding it in the code. You may be thinking that this is how it will always be. No, that's not how it's always going to be. When you are creating a variable, if I know that these are the members that I've shown you here, if I know that these are the numbers that I'm going to be adding up with this function, then why put it there at all? Why will I have to put it there if I know that these are the numbers? These are just examples to illustrate them. That's what we are doing. But essentially, what is going to happen is that the numbers will be provided, or the values in that variable list will be provided when the person is ready to run the program. Do we get it? So this our function here could actually be a function that we have created and added to a library that people can call and use in their own case. So just like the printf function, thank you. Let me use a printf. So printf function, what do you do? When you write printf and you write this and you do %d, probably you write something, then you do this, okay, comma. How many optional variables do you put here? Since it's only the %d is only one, you put one here. I mean, you put just one argument here, so it could be 40 here, okay? But if I write printf, this %d, %s, %i, then I do this. You know, I have to provide 3 arguments here. This will be a string, so Obed, then this will be, say, 16. So the way the printf function is able to tell how many optional, so that it goes to print each of them, the way it's able to tell that is by counting these percentage signs. How many of these percentage signs are in there? It realizes that, oh, there are 3 of them, so they have to be 3 optional arguments. So our goal right now is just to find a means to count the number of optional arguments there. So you can also do something like that, okay? But this is a bit advanced or more demanding. So the easiest way is that I can ask the user, how many items are you going to be providing here? Don't forget that when you're calling v_arg, you also need to know whether it is a string, whether it's an integer, it's a decimal, whatever it is. Okay, so that is how the printf is. Probably after this one, now we'll be in a good position to tackle the printf project. So we'll look at it later. But the point I'm making here is we are interested in knowing how many optional values are provided so that we don't leave any of them out. If there are 10, we need to operate on them, we know that there are 10, so let's go and operate on 10 of them. If there are 20, then we need to operate on 20 of them. Nothing more, nothing less, depending on what we want to achieve. So the question is how? And I've showed you that in printf is able to calculate, like they've written the code to be able to determine the total number of these things, the percent something. Once they see percent with a format specifier, they count it as an optional argument. So if there are 3 of them, then I expect there are 3 optional arguments. So if there are 3 of them here, and you leave this out, printf will give you a warning, like there is an error, because it was expecting 3 optional arguments. So our quest now is to find a way to get how many optional arguments. And I said the easiest way is just provide a variable in your function. So we are writing a function called sum. So in this particular function, our interest is, okay, let's provide a variable or an argument called count. And what this argument is going to do is it's going to take the total number of elements or optional argument that this person is going to provide. So I can even do this and do comma dot dot dot. Okay, this tells me that, okay, before I even run this program, I'm probably going to use scanf to ask the user, how many elements are you going to be summing up? And the user says 5. Okay, then I use scanf to take them one after the other. So what are the numbers? 20, 40, 44, 28, and 59. So these are the 5 elements that the user wants to add up. Okay, but now I know that there are 5 of those optional ones. So when I go into my list and I check v_list, which I've given the name my numbers, okay, and I initiate the list with v_starts by passing the name of my list, my numbers, comma counts, because count here is what comes before the argument that comes immediately before the dot dot dot. So we put it there to initialize it. Then now I can write a for statement, a for loop, because I know that there are 5 optional values or 5 optional arguments. So I can write, let me initialize int I, okay, int I. Then I'll say I is equal to 0 here. Then I check if I is less than 5, because I know that there are 5 of them here. Okay, so when we are writing the actual definition, we'll write count here. If I is less than count, then we increase I. Inside this statement, we are only going to be calling arg the name, which is my number, then the type, data type, which is an integer. So assuming that we are just printing this out, we can write a printf statement that will print this value out. So if we go ahead to print them, the first print will be the first number. So 20 will be printed out. That is when we come in, I initially is 0. So the first one will be 20 to be printed out. The second one will be 40. Third one will be 44, 28, and 59. Then that is how we are able to get all the 5 elements printed out. So our goal is to get something that will tell us the total number of optional arguments that were provided. You can do this in several ways. Just that when you are passing the information to the function definition, just count it in a way, like pass a value to it that will help you determine the total number. Okay, so when we are working on the printf project, you realize that we will be counting this percentage format specifiers. We will count them and know, okay, there are 3 of them. If there are 3 of them, it means that we expect 3 arguments. Then we'll go ahead and have access or try to access those 3 arguments. Does that make sense? Can I now go back to my code? Any questions? Yes, any questions? Okay,
Yeah,
so
you
let's
can
go back
proceed.
to it. All right, good. Oh. Okay, so maybe I should write some too. Okay. Where did we end? There were 3 of them, so let me.
Doc, sorry.
All right, go ahead.
Is it a must? Does it mean that it's a must that will ask the user for information?
No. So far as you can figure out how many optional values that you want, that is it. Okay. You can decide, like just as I said, if let's say I created a form and I needed to print out all of them. I created a form, and in the form, the person is supposed to provide name, password, email, GitHub username, contacts, address, all of these things. Okay, but let's assume they are all even optional. They are optional, but I want to be able to print out what the person passes or write or submit. So what I'm going to do is that for each of these, after the person has submitted a form, I'm interested in knowing which of them is not empty. So if I check name is not empty, then it means I have one here. Password is not empty, then I've gotten 2. Assuming email was empty, this was empty, this wasn't empty. So now there are 3 of them. This wasn't empty. I didn't ask the user how many elements did you enter, but by myself checking which of them was not provided, I'm able to tell that there are 3 optional values that have been provided. For that matter, if I go out to print it, I'm only going to print, or I'm only going to be able to access only 3 things. So that value that we are looking for is not part of Variadic functions. Like, it's not a part of it. We don't need it for them. Except that for us to effectively access the members of the list, that is a strategy that we should use. Because there is no single way that we can just go and say, okay, for this person, the person passed 5 variable options, or 5 variable arguments, or 5 optional arguments. There is no straight way to do that. So you better have to come up with a way that you get to know how many optional arguments the person provided, so that you go in to the list with the help of what? A loop, and get exactly the total number of options that they provided. That is the essence. So you don't need to ask your user, but if that is the only way for you to tell the total number of elements they are going to add, or they are going to input as optional arguments, then you have to go ahead and ask them. But you can come up with your own way of counting. In fact, I say that when we do the printf project, we will get to see how we count them. We are just looking for something, the percentage sign, and something that follows it. And if we meet that, we count it as 1. Then if we meet another one, we add on. We meet another one, we add on. So we can have several ways of counting them, okay? But specifically for this sum function that we are writing, that's the easiest. And you realize that when you check online for examples of Variadic functions, almost all the information, if you don't take care, you end up thinking that it's compulsory for you to ask the user to input the value. That is why I didn't even start talking about it. Now that we are about to end, then I bring it in, because that is the only way that, that is the one way that will help you access each member in there. Okay, so any way for you to tell the total number of optional values or optional argument that was provided, you're allowed to do that.
Sorry,
Marcel,
Doc,
do you want to
can
say
we,
something? Right.
yeah, I want to say, can we use sum of infinity? Like in that sum, you use trade dots to show continuity, right?
Mm-hmm.
Is it applicable? Can we use it to, instead of asking the person for the total number for the count?
That we're expecting up to infinity. Is that what you're saying?
Yes. Just like as calculator
if you
work,
say up to infinity,
if you keep adding, if
you say up to infinity, then we're expecting that your loop will run up to infinity. Do you get it? The loop that you are creating will run up to infinity, and which doesn't exist, so we'll keep running. Okay, so it wouldn't really make sense. We are only bringing that value in there just to cap us. We know the person can add as many elements. So if somebody adds 3 elements, we don't want to count more than 3. Like, we don't want to go looking for more than 3 elements in the list that contains only 3 elements. And if somebody enters 40 elements, we don't want to go counting below 40. We want to be able to access all the 40 and nothing more. So the only way we can do that is to find a means to determine how many elements are in there. And this can be done in several ways, but it cannot be done when you are writing your program. So in writing your program, all that I'm saying is that one of the mandatory arguments, just say that one of the mandatory arguments, just pass it as count or any variable name that you want. Okay. And in your mind, bear in your mind that however you are going to use it, you want that particular variable or argument, that particular mandatory argument, you want it to represent the total number of elements that a person will use. So however you are going to get that is up to you. And the program, the type of program you are writing is totally up to you and the type of program you are writing. All that we care about is that have in mind that this my program is going to accept a variable number of arguments, but at any point in time, I'm interested in knowing how many of these arguments were provided. And I'm going to store that in one argument or a variable called, say, count. So that with the help of count, I can use a loop to access each member in the list. As simple as that. So now when you are writing your program, then you don't begin to ask yourself, how will I even know the total number of optional argument a person will provide? And I've suggested one of the ways. One of the ways is ask them, how many numbers do you want to add? Okay. The other that you can do is maybe you want them to add them. So probably you can even use a loop to let them add. So what we can do, let me show you another thing. I don't want to be illustrating all of these because it will take forever. Another thing we can do is let's use a loop. Okay. Probably a while loop. And we want you to be entering the values. So we are using scanf. But anytime the person clicks 0, that is the end. Or let's say full stop. Okay, so I can tell the person that enter all your values or equal to, I think equal to will make more sense. Yes. So I expect to see this character. So now you keep on adding your values. Add. Then I'm using a while loop to go through it. So for as long as this value, let's say X that I'm checking, that's what you are entering. For as long as it is not equal to the equal to character. For as long as this is not equal to the equal to character, let me increase count. Okay, so I'm interested in how many elements that you enter. So you enter. Let's say you enter 10 elements. That means I've counted 10. Then you enter equal to. Now this loop will break. My count is 10. So I know that you have provided 10 values that I'm going to use in my calculation. That's just something that I just thought about. Okay. So there are several ways that you can get to know exactly how many elements you are going to be operating on. But it depends on the kind of program or function or product that you are trying to build. Okay. That is at the verge of you building. That is when you know that, okay, let me accept 10, 20, 50 elements here. And this is how I'm going to access it. Do you get it? So it is variable. The number that you are going to accept is variable, but you have to come up with a strategy to get the variable number. And the easiest of them is just asking your user, how many numbers do you want to add up? Or you wait until they've entered all their numbers, and you ask them, how many numbers did you add? Yeah, so that's just by the way. It doesn't mean you should go and ask them. There are several ways that you can get that number. But the essence is that in the function that you are creating with a Variadic function, it's good for you to pass the total number of optional elements that a person will pass, so that you can use a loop to access them. As simple as that. So let's try practicing the one that we have said before I take any other question. I think that would be like the last bit. Okay. So let's write sum 2. Let's write sum 2. Okay. Paste this and save it as sum 2. Sum2.c. So instead of calling them one after the other this time around, no, that's not how we are going to do it. We are going to use we're going to use this, what we have learned right now. Okay, so our goal right now is, let's even ignore these ones. We don't want any mandatory ones here. The only mandatory one that we want is for us to know how many elements this sum function has taken. Okay, how many elements they have taken. Okay, then once we have this, what can we do to access them? We can write a for loop in here to access each of the members of the list. We can write a for loop here. So let me just comment, accessing all members of the list. Okay, so to access them, what we are going to do, let's write a for loop. Then we say, okay, I should also declare one more integer called I, and let's assign this to 0. Then in here we say I is equal to 0. Then we are checking, is I less than count? Because count could be any number. Is I less than count? Then let's increase I for each round that we go in there. So now results that we are looking for is equal to the original results plus the value that we are going to access now, which will be done with the help of v_arg. Remember, the first time you call it, it will give you the first value, the second time, the second value, in that order. So we pass the name of the list, then the data type. So it is an integer in this case. Go ahead like this. Okay, so at the end of the day, this is going to add up all the numbers, because the first time it enters, it add the first one, we increase I, comes in here, add the next one, increase, comes in here, add the next one. Okay, so hopefully this should help us add up our numbers. How many have we provided here? Remember that you have done int count, the mandatory one, as the first thing here. That means that whenever it is called, the first one will be considered as that counts. And in your code, this is what you use count for. So here that we have 4 in here that we have 4 here, it means that when we go into our code, this part will be changed to 4. So we are going to run this loop 4 times, because we are starting from 0. We'll go increase 1, 2, 3, 4, then we won't enter again. So that is from 0 to 3 is 4 times. We are going to enter this loop 4 times. That means that v_arg is going to access 4 elements apart from this, because it starts counting from what? The ... and not the mandatory ones. So it's going to start counting. This will be the first time you run in, the second time you go in, the third time, and the 4th time. Okay, so hopefully if everything is working, sum 2 should also work for us. Let's go ahead and run sum 2. Sum 2. Compile it. No. What is wrong? Why? We've taken y away. Yes, we've taken y away. So now what comes before the ... is count instead. So we have to remove y and put count there. Good. I hope that's the only error we had. So let's recompile it. Let me clear this. Recompile. We still have another sum. Are we not returning anything? Oh, what's happening? What did he say? In sum, conflicting types for sum. Okay. So see this, our prototype. We've not changed our prototype. So let's go and change our prototype. Count, comma, All right. Hopefully this time around we shouldn't get any error. Good. We didn't get any errors. So run it and we get 1/4. Let's see if that is right. 45 plus. Please be mindful that the 4 here is not going to be added. The addition that we have done, we didn't include a 4. If we wanted to, we could have included it. But this time around, we had a purpose for the 4. And it was just to serve, to give us an idea of the total number of optional argument that was provided. So we didn't add it. So we are adding these ones. 45 plus 5, that makes it 50. And 65 plus 25, that should be what? 90. 90 plus 50, that is 140. Did we get 140? I hope my math is still good. Okay, 140. So basically that is how to go about it. But now that we have written this program, now we can go ahead and add as many as we want. Okay, just write as many numbers as you want, and this your calculator will be able to sum it up for you. This is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 of them. So just tell it that there are 8 of them here. Recompile the code. Then it should be able to add and give you the right value. So now we have created a Variadic function in that no matter the number of elements that you decide to add, you'll be able to add them up. It will be able to add all these numbers up. Unless if you exceed the maximum for the size of an integer, then you're going to get an error. But this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 of them. I hope they don't exceed the maximum that an integer can go. Let me try it anyway. Okay. Okay. Hopefully it is correct. This is, well, that's what. Hey, is that it? So 1 million. 1 million something. So we're expecting 2 million. Okay, that's 2 million something. Yeah, that makes sense. Oh, this is more than that. No, this is no more than 1 million. There's 7,000. Okay, so hopefully this is the right answer. All right, but that is essentially what we were interested in doing, to have our code add up a variable number of arguments, and that's what we have been able to achieve here. Hopefully you understand these things. Let's pause here and take questions if there are any before we bring the session to a close. Any questions?
Doc.
Yeah.
That when that at the main side, that n equals to other stuffs.
Yeah.
Yeah. When you kept on changing the first number, the first index, kept on changing the first index, does it mean that the while loop, the for loop that you ran, that you added in the program, that's what will be telling that first number to keep changing, changing like that?
Yeah, exactly. So once now it is 13, it means the for loop will be run 13 times. If you change it to 5, it will be run 5 times. So now let's change this to 2. If we change it to 2 and we run this program, it's going to run and add only these 2. So you're going to get 50. Because our for loop is running depending on the count. Okay, so even though all of these are provided, if it is 2 and it's counting 2, it's just going to add only those 2. So let me compile it for us to confirm. Sum 2, compile this, run. You get it. So it added only what? 45 and 5, because your count value is 2. In the same way, we can decide to count only 3 of them. We can decide to count all of them. We can decide to count any number, but it will go in the order. This is the first one. This is the second one. second one, third one, fourth one. So the for loop will be run based on, depending on how you write your code. We have written it like that. So the for loop will be run based on that. Does that make sense?
What of in a situation whereby we decide to remove that n equals to something? Does it mean that's when we'll bring in the scanf to ask the user to put, then the count will be able to count whatever that the user has put already? Then sum them up.
We could have done, say this n is nothing. I just wanted to pass it to this. So the output of sum is being assigned to n, then I'll use it to print it. So it doesn't affect anything here. So we have written scanf here to get even all of these inputs. Okay, I'm not interested in those ones. I'm just interested in you understanding the Variadic function. That's why I didn't go that route, and I'm providing the values here. But we could have written scanf to take, let's say we have another integer called my counts. Okay, then we pass this to address of my counts. Then here will be my count. This means that if I go ahead and run this program, depending on what number I put here, the respective number will be added. So if I put 4, only this 4 will be added. If I put 2, only this 2 will be added. If I manage to get all the numbers accurately, then those ones are going to be added. However, you can also write scanf to take in all of these inputs, one after the other, before you will come and pass it as an argument to this function. Okay, but my goal here wasn't with regards to the getting the inputs and things. My goal was just to illustrate and make you understand Variadic functions and how they work. That's why I didn't dwell on that. But this is going to work fine. So when we run this program, the first thing is for us to enter something, even though it doesn't say anything. But if I go ahead and enter 2, then 2 means the count is now 2. So it adds and give me 50. Okay. If I run it and enter 13, then it's going to add all of them and give me the value. I can run it and enter any number at all that I want. That is the first 5 numbers. Add them and give me this response. Any other questions?
That's fine.
Let me see the function that we have, the one down. Yeah, because I don't know, I was getting a bit of an error here. I don't know where I was making.
So let me reiterate this. The important ones are this, the macros here. So the first one, that's the list, the name of the list. Give the list a name. Then v_start is what initializes the list, and you do that by passing the name of the list as well as what precedes the list. So the last argument that precedes the list, that is what you pass here. Very important. Then the next thing is accessing the members with this. Okay, so every other thing is not part of a Variadic function. It's part of your own write-up, whatever you want to do with it. What makes this Variadic is with the help of these. Well, this is what makes it Variadic. Sorry, the dot here is what makes it Variadic. But to access the members or the optional arguments, you need all these 1, 2, 3. In fact, with just these 3, 1, 2, 3, it's going to work perfectly, even if you leave this out. Okay, but it is recommended that you add this so that you know that you have ended the list. That's all. Every other thing is for you to come up with your own thing. Just remember that if this is run one time, it takes the very first number. If it is run again the second time, it takes the second number, third, like that. Okay. Any other questions?
And thanks so much. I understand.
You're welcome. Any other questions? If there are no questions, then we'll bring the session to an end here. Thank you for coming. I respect you for spending your time here, and hopefully we'll meet.
Thanks a lot.
Tomorrow we can't meet, so next week we'll meet. All right, thank you. Bye-bye.
Thank you, sir.
Thanks so much.
Thanks a lot.